Hey guys, do you get your periodic table questions wrong? Are you unable to calculate atomic radius, or you are unable to arrange the elements according to their atomic radius, effective nuclear charge, ionization enthalpy, electron enthalpy, hydration energy, electronegativity, or lattice energy? So in this video we will discuss all these terms. Okay, so let's start with atomic radius. We will denote it by small r. Now, first thing to see, uh, there is some confusion that what is Z by E. Actually, Z means atomic number, and E means not the electron charge. It actually means number of electrons that element has. Now, smaller this ratio will be, smaller the ratio will be, larger the size will be. Okay, now let's take some example of it. Like we are having F minus Ne Na plus. Now if we will calculate the electrons, we will get 10, 10 and 10, and if we'll see their atomic number, it is 9, 10 and 11. Now if we will calculate the Z by E ratio, we will get 0.9, 1 and 1.1. So according to the theory, we will get F minus is larger in size of F minus is larger than neon, and it is also larger than sodium. Okay, now what's the trend in the periodic table of atomic radius? It's like this. Along the period, atomic radius decreases because effective nuclear charge, we will discuss about it later on, effective nuclear charge increases, and down the group, number of cell, that is principal quantum number, increases. So automatically radius will also increase. Now radius of an inert gas, okay, radius of an inert gas in a period is largest. Okay, and one more thing you guys have to remember is an ion is always greater than neutral atom, and neutral atom is also greater than its corresponding cation. Okay, this thing is very important for for uh, distributed charge atoms. Okay, many questions are based on it in JEE. Now by this much information, you all can get all your atomic radius questions correct. Okay, now we will move on to effective nuclear charge. Effective nuclear charge, we will denote it by ZEFF. And now what actually the effective nuclear charge is? So we will not go to its main theory or definition. We will just talking about tips and tricks to calculate all the information and get all our elements arranged in the right order. So effective nuclear charge is atomic number minus screening constant. So this sigma is known as screening constant. Now let's know what this screening constant is. So screening constant is directly proportional to number of inner electrons. And one more thing, how to calculate the screening constant? So first of all, you have to divide the whole electronic configuration into two categories. One is SP and another is DF. And in SP, before telling that, I want to tell you that um, um, screening constant for right of the group is 0 and that of left is calculated likewise. Like I'm going to tell you, um, if, if you want to know the screening constant of a specific group, then n will be in SP category, n will be 0.35 and minus 1 will be 0.85 and that n minus 2 will be 1, and in DF category all these things will be only 1. Okay, so these are the values of screening constant. So read books and then you will understand how to calculate. Now ns is greater than np greater than nd greater than nf. So this is the order you also have to remember, and going like this: screening power, that is penetration effect, so it decreases. Now what is screening power? Screening power means the nucleus is attracting some electron. Okay, now screening power, how the variation is in the periodic table, it is increasing and increasing. Another thing you can calculate like this, so it's not that hard. Okay, now we will talk about ionization enthalpy, delta Hi. Okay, so by those much information you will get all your atomic radius and all your effective nuclear charge questions correct. Now ionization enthalpy. So what is ionization enthalpy? The minimum energy required to remove an electron from an atom and turn it into positively charged ion, that is cation. So if the energy is called, if energy is at 273 Kelvin, then it is called ionization energy, and is if the temperature is other than 273 Kelvin, it is called as ionization enthalpy. So this is the point of difference between energy and enthalpy. And now moving on to its variation. Okay, so one more thing guys you have to remember is delta Hi1 is always greater than delta Hi2, and so on. Delta Hin is always greater than delta Hin minus 1. So this is the major point of difference. Now one more thing you have to see is ionization energy is always directly proportional to 1 by radius, that is inversely proportional to radius. Ionization energy is directly proportional to effective nuclear charge, and it is inversely proportional to screening power. Now along the period it increases, and down the group it decreases. One more thing which will help you in solving your question is full filled is greater than half filled is greater than partial. So what is this? This is actually a stability order of the atom. If the atom is more stable, that is it is having full filled orbital, half filled orbital, partial filled orbital, then it will be hard for an atom or something, some mediator to remove an electron. So it is not possible to remove an electron from stable configuration. Now for group, now for period 2 and 3, you can solve question by this graph. So what is this? This is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Something's wrong. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay. And so likewise it is of third period also: sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Now one more thing: noble gas has highest ionization energy in their respective period. Low ionization energy means it is a reducing agent, and it is also basic in nature. So by this much of information you can solve all your ionization enthalpy questions. If any doubt, you all can comment, it's free. Now let's talk about electron gain enthalpy. So it is denoted by delta HEG. So what is this? This is to add an electron into a neutral atom and turn it into negatively charged ion. Okay, so it is quite opposite that of ionization enthalpy. Now its variation in periodic table is like, along the period it increases and down the group it decreases. Same that of, okay. Now what is the difference between electron gain enthalpy and electron affinity? Many questions are asked. So electron gain enthalpy is equal to minus of electron affinity minus 5 by 2 into RT, where R is Rydberg constant. R is universal gaseous constant. Now electron affinity is directly proportional to 1 by radius, and it is directly proportional to effective nuclear charge. Now same concept of half filled and full filled, half filled, partial. The stability order will also be mattered in this case also. And one more thing guys you have to remember is elements of second group, that is beryllium, magnesium, calcium, strontium, barium, all these having their electron affinity 0. Now some relation between reducing nature and oxidizing nature. So down the group, along the period, it increases and decreases, reducing nature. And oxidizing nature, along the period it increases and down the group it decreases. So this much information are enough for solving any question of electron gain enthalpy. Now let's go to the other page. So electronegativity denoted by chi, it's Greek letter. So variation in periodic table, it increases along the period and decreases down the group. And electronegativity is directly proportional to 1 by radius and directly proportional to effective nuclear charge, directly proportional to positive charge, and directly proportional to S character. Concept of hybridization. Now, how to know that a compound is ionic, covalent, or polar covalent? So we'll see the bond of AB, and if electronegativity of A is equal to electronegativity of B, then it is known as covalent bond. And if electronegativity of A is greater than electronegativity of B, it is known as polar covalent bond. And if electronegativity of is much greater than electronegativity of B, it is known as ionic bond. Okay. Now there were three scientists who have determined the formula of taking out electronegativity. So one was Pauling. As a result of taking out electronegativity difference between two element as bond and enthalpy of AB minus half bond enthalpy of AA plus bond enthalpy of BB, and the other was Mulliken. This question was asked once in IT. So electronegativity of A barabar ionization potential of A plus electron affinity of A by 2. So it is average of ionization potential and electron affinity. The unit is electron volt per atom. Now the last one was Alred Rocca. So his formula was 0.36 into effective nuclear charge upon radius square plus 0.74. Now one more thing I am to tell you about magnetic moment. So it is calculated like under root number of unpaired electron bracket and plus 2, and its unit is Bohr magneton, and 1 Bohr magneton equals charge of electron upon into Planck constant upon 4 pi mass of electron into speed of light, and its unit is coulomb into meter. It is coulomb into meter, not centimeter. Coulomb meter. Now we will talk about charge density, that is polarizing power, denoted by sigma. Phi. So it is calculated like ionic charge upon ionic radius square, and its variation in periodic table is it increases along the period and decreases during the group. Now, what is inert pair effect? Inert pair effect. So inert pair effect states that it's down the group. If you are going down the group, tendency of s electron decreases in bond formation due to ineffective shielding of ns2 electron due to intervening of d and f electrons. If d and f electrons intervene, s will not be able to make bonds with other elements because d and f will make. So it is much inside. So this effect is known as inert pair effect. If there is question about stability of 2, if it is asked that why ns3 is more stable than ps3, so and why ns3 exists but nh5 does not. So this type of question can be solved by these 4 points. You have to see that electronegativity is enough to excite electrons. Is there any vacant d orbitals are present or not? If there is no vacant orbital, then how the NH5 will exist? There are no vacant d orbital, so no more electrons, no more bond formation. Another is inert pair effect, and the last is size of ions. So one more thing is, if polarizing power, that is charge density, increases, then covalent character will also increase and melting point decrease. So this is the method of calculating the melting point. So the last two topics I want to cover are lattice energy and hydration energy. There are many questions asked on it, how to arrange them. So along the period it increases and down the group it decreases. This also along the period increases and down the group decreases. And to calculate lattice energy, to see the variation, you can go by this formula. U naught, that is lattice energy, is directly proportional to magnitude of positive charge into magnitude of negative charge upon radius, or delta HU equals enthalpy of formation minus enthalpy of sublimation minus ionization potential minus electron affinity minus half enthalpy of vaporization minus half enthalpy of bound. Okay, now for hydration energy, delta H hydration, enthalpy of hydration is directly proportional to charge density. And the last thing, if lattice energy is less than hydration energy, the salt will dissolve, else salt is insoluble. So guys, thanks for watching this video. I don't think that any of the question now of periodic table will be not solved by you. If any problem, you all can comment. This video is rough video because I am far from my setup and unable to give much time on editing and all those stuff of animation. So guys, thanks for watching. Stay subscribed, stay updated. We'll be back after a month.